Hi everyone, I would like to welcome you all to the second day of BOUWHOUSE Symposium. The event is a collaboration between the different master's track of architecture offered at the TUDEL faculty. I encourage you all to look up for the event on the Stylos website and join the lecture and the workshops you might like. Today, we will be talking about building technology. It is a master's track offered at the architecture faculty of TUDEL. For this, we have our Professor Marcel Billo from the Chair of Building Product Innovation, who will give an overview of the field through students' works from previous years, our alumni's career paths, and what building technologies bring to the industry. I will hand it over to Marcel now.
Thanks for having me. Hi, everyone. Yeah, it's a pleasure for me to talk about building technology today. And first of all, the question, what is building technology? And within the next 45 minutes, I'd like to share these various topics with you. And I first would like to show a little bit of an overview of what you can await from this. So we will talk about why, who, about the persons and the people we are looking for, how. It's a little bit about our educational program. And we will also talk about what's happened after you have mastered this track. But let's start with the question about what is building technology. If you look around and on the screen, in principle, building technology is in every of the building. If you look out of your window, if you look around your room, wherever you are sitting right now, there's a little bit of building technology in every of these. In principle, we always say that's the link between architecture and civil engineering. It's a little bit like a translator who understands the architect's needs and is able to translate that into a set of drawings, documents that those within the building industry are able to make these architecture real. But let's start with a problem definition. Why is building technology? And within the next couple of slides, I would like you to introduce to the topics that drives us and the problems that we find ourselves surrounded by. So building technology is a way to create a comfortable, productive, and safe environment. It's to solve the growth of population. It's to reduce waste in the built environment. It's the question about how to power our buildings with renewable energy. It's to create buildings that last longer and to reduce our carbon footprint. And we are also seeking and being driven by the idea to create buildings and building products that are circular. And not to forget, we are also there to help architects to boost their dreams. But if you talk about a person who does building technology, who is that person? We think it's a team player. It is someone who cares, is creative, also is known as an expert. And we have to say, also a little bit of a nerd. And the architect's best friend. Within our master track, we do teach various different corners of that field, which is quite broad. So therefore, the question, how is building technology, we would like to show the different scales in which we are dealing with the topic. There's a product level where we talk about sunshades, windows, facades, load-bearing structures. There's the entire building itself, understanding the physics behind how the environment changes the human comfort within a building. We see the facade as a layer that has a big influence in that. And we see it also on a city scale. How does transportation, streets, but also the urban fabric changes the way we are able to live and communicate within the city. At the very end, you are free to choose from the various scales within your graduation topic. So it's either up to you if you think about product development, something that deals with the building scale, or maybe even on a city level. And within our field, we have 4 main domains, which is facade and product design, climate design, structural design, and design informatics. Within these 4 different domains, we try to teach you the essential skills that are needed in order to tackle the problems I have been able to share in the beginning. We have asked our students to share a little bit their experience and to explain in a few minutes what they have encountered within our various courses, and especially based on the different scales. So on a product scale, we have the Bucky Lab, the first semester, and I'd like to share the first video.
Hello, my name is Sarah. And I'm Pragya. And today we're going to share with you our experience of the Bucky Lab course during our first semester Building Technology Masters. For the design course, we had a 6-person team representing 3 countries and 2 different technical backgrounds, and we were tasked to create PV technology on facades. We pitched our individual ideas during the first month and came together as a team.
We were able to bring architecture and engineering together for a creative design process during the 13 weeks, and we designed a modular product which emulated the look of a brick and could be flexibly installed to get different brick patterns on the facade. We arrived at a unique product which is essentially a solar powered brick.
During our design process, we were able to talk to experts from the PVMD department at TU Delft, and we were able to determine the best PV material and application. The flexibility of PV technology allowed us to apply it in our design with ease. Our design changed throughout the project based on research and other design factors such as the ease of mounting and replaceability. Our team created various ideas and concepts and looked at each one critically.
We utilized software such as EduPack, which were introduced to us during the Bucky Lab engineering courses to come up with a suitable material, and we used knowledge from our structures course to be able to decide on a target construction type. We also used computational design to visualize efficient placement of our product on a shaded facade. We went from sketching ideas on paper to working with real materials that resulted in some very practical insights. And here are some of the results from building weeks.
Don't misunderstand us. As individuals on our team, we started week 1 with different visions of what our product would end up looking like. But by the end, we found a common ground through the design process and came up with our final product, the energy brick. The Bucky Lab course for building technology was a unique experience to work closely with students of different backgrounds and to learn more about the technical and practical application of architectural design. We hope to see you next fall in Building Technology Masters.
Thank you for your time.
If we go up one scale higher to the building, we have Mega, which deals with a huge project and a nice setup in which the students collaboratively work in a team.
Hello, my name is Shreya, and today I'm going to share my experience of the MEGA course during the 4th quarter of my Building Technology Masters. Along with a team of 8 students, each responsible for their own discipline, we as a team took on the task of creating a skyscraper called the Tree Tower. The design of the Tree Tower rests on the foundation of the team's vision. The vision was used as a starting point throughout the entire design process. The tree tower acts as a multifunctional building merging industrial, commercial, and residential real estate. With this unique combination of program, the tower is envisioned to be a hub for the surrounding Makers district. A clear distinction was made between the transport of goods and that of the people. By locating the entrances for different functions in separate positions, the transport and logistic flows are smooth and efficient. Similar to how a tree adjusts to external factors, wind and sun played a key role in shaping the tower and determining its orientation in space. The roots of the tree are interpreted as the part that collects goods, which then will be distributed inside the building and its environment. The concrete core, posing as the trunk, is used for stability, yet it also realizes the transport of water, air, and energy. The green terraces correspond to the branches of a tree. The green areas are positioned in places that allow for maximum daylight to enhance growth. This course was a very good experience while working off campus and communicating through online collaborative platforms. It not only enabled me to guide the group as an architect, but also enabled me to understand the issues related to the other disciplines and come up with a suitable solution. This course allowed me to push my boundaries and explore the different specializations in the field of building technology. Transforming tomorrow today. Can you see it coming together? This is how we did it. I hope this gave you some insight on the courses of building technology. I hope to see you soon and good luck.
That was mega. And if we continue on a building scale, but a little bit broader, we have extreme, which deals with a bigger scope.
Hello everyone, my name is Vicente Blanes, Master Student from Building Technology, and in this video I will present my project for the Extreme course of 2020. The topic was centered on the development of Ebola or COVID-19 emergency treatment units for El Congo. The challenges for this study were given by the complex context of El Congo and the necessity of improving the safety measures for the healthcare personnel. On my project, the idea was to create an adaptable structure that could later be used by the communities for other functions. For this, the main structure was designed under a modular configuration to attach more units in a linear way, and to accommodate multiple functions and provide flexibility for the spaces to be adapted later on. For the distribution of these units, an algorithm was developed to analyze the site of intervention and determine the position of the rows of units, avoiding obstacles and following the topography to create leveled corridors. The structure of these units was designed with wood pieces of simple shapes and cuts, which are then mounted together to build the main modules for the floor, walls, and roofs. A lot of focus was given to the assembly logic as well, to facilitate the construction and reduce the time and the amount of workers required for this process. For the passive climatization of these spaces, a concept of hybrid solar chimney was implemented with the goal of incrementing the ventilation on the rooms. The system was combined with a mechanical air inlet to create a positive air pressure corridor for the safety of the healthcare personnel. These were the main highlights of the project. It was a very challenging exercise that required an integral approach of an architectural, structural, and climatic solution to respond to the given requirements. You can see the projects of our batch and the ones from previous years on the Extreme Architectural website. I hope you enjoyed the presentation and thanks for your time.
Yeah, thanks. And next to that, we really like to have a hands-on approach, and therefore we are battling within the Solar Decathlon competition, which is a worldwide competition where our team of the TU Delft have battled against other universities, and last year they were very successful with the second prize and the highest number of prizes at all during the competition in Hungary. And I'd like to share a short video that shows a typical day on the building site in Hungary. No, sorry for that.
Mamma mia! We're coming to the site. It's me.
It's crazy what the heat can do with people. It's crazy. So we're going back to the site again, day 6. And it's pretty hot out here. It's like 1,000 degrees or something. People are just melting, becoming puddles of human blobs or something, I don't know. But yeah, we have to continue building, and let's see how the building looks right now. Hey, how you doing?
Good. It's warm. But okay.
Lesba, how are you doing?
Good. Doing good. I'm doing great. Actually, yeah.
So what's happening is now is that a wall element will be placed on its right place on our building, and that with the help of a huge crane and with the help of some other people it will eventually go in its right place. Shift 2 is now preparing for the briefing about what has to be done today, and well, everyone is going inside.
They were raising the flag?
We're raising the flag?
Yes.
We're raising the flag. Nice.
We're raising the flag.
We're raising the flag. Let's do it! Whoa.
hold your breath. All the moves we're making. Oh boy, you got.
And of course, after a long day of hard working, we also get to treat ourselves a bit. So tonight we have a special occasion and we're going to barbecue with the whole team, so it's very nice.
Music's something you adore.
I think that was a very nice impression of what you are about to do if you decide to follow the Solar Decathlon project. Next to that, we have a more computational based program, which is Earthy.
Hi, I'm Anaga,
Hi, I'm Twinkle.
and we will share our experience from the MSc3 Design Studio titled Earthy.
Our project Raha translates to Recreation Activity Hub Actuator in Al Jatri camp in Jordan and was achieved by a team of 5 members. The main requirement in the camp is to necessitate the holistic well-being of refugees. The proposed intervention is therefore a recreational hub that allows for various levels of human interaction. The whole project is divided into 4 stages: configuration, shaping, structuring, and constructability. The configuration process started with site selection that was based on a computational algorithm. The different program requirements were set and their connections were studied through bubble diagrams. A metrolink diagram was made to understand the spatial hierarchy. The shaping process began with a gradient descent optimization that generated possible spatial configurations. The next step was to translate this into a working floor plan. For this, a tartan grid was used to ensure flexibility and adequate room size. The shaping process ends with the configured design.
The configured design then enters the structuring process. Here, the focus is to design the roof typologies such as domes or cross walls using the principles of tessellations, which are relaxed as meshes and then approximated into surfaces. The primary construction material considered is adobe bricks, and its material properties are used to analyze the structural performance. To test and understand the constructability of the proposed design, an experiment was carried out. This inspired us to think about the practical challenges for which we designed a tool to support the construction while eliminating the use of additional formwork. This year's aim for Earthy Design Studio was to design a challenging Adobe 2.0 structure that has not been realized so far in reality. For this, a lamella dome tessellation was visualized. This was our journey through the course, and we hope you enjoyed it. Thank you.
Yeah, thanks for this example. And when everything brought together from the various scales within our educational program, you are about to choose your own graduation topic. Supported by a team of 2 members from different chairs, we are able to share knowledge, and therefore we have Aditya, who will share his graduation project about
Hi, my name
the
is
use of
Aditya, and
robotic
my
construction.
graduation project is called Robotic Restoration. Stucco ornaments can be found all across the world, and in the Netherlands especially, we find them in the form of ornamented stucco ceilings. Unfortunately, these ceilings are quite fragile and they can damage over time. Traditionally, they are restored on-site and by hand, but this is a disappearing craft due to several issues in this field. So the question becomes, how will we be able to restore these ornaments in the future? My proposition is to use 3D scanning, digital reconstruction, and to restore them by 3D printing them directly onto the wall or ceiling with a robot arm. And for my project, I focus mainly on this last aspect. The result is a set of new tools for restoration. They include a 3D printer extruder, which I designed and built myself, which can be attached onto a 6-axis robot arm, which can be then used for 3D printing. I also worked on the printing material itself. And here you see several experiments that I conducted to find the right composition of this material so it could eventually be 3D printed upside down. I also worked on the robotic platform. This robotic platform consists of stabilizing legs and a crane onto which a robot and extruder can be mounted. So what would this new restoration methodology look like for stucco ornaments in the future? So imagine we have this damaged ornament. This ornament will be first 3D scanned. And this is the geometry that we acquire. Next, the missing geometry is modeled. After that, the missing geometry is sliced in a 3D printing software and eventually put into a simulation software for the robot toolpath. The restorer brings the robot platform to site, stabilizes the platform, mounts the crane, and the robot is ready to print. It then approaches the ceiling and autonomously 3D prints the ornament on site. And this is how the ornament is restored. And by doing so, helps us to preserve our collective cultural heritage for future generations.
So while this was quite a hands-on approach, we also deal with topics that are more on within the field of building physics, for instance. And Pratik made a very good project in order to think about how to make our buildings more resilient.
Hello and welcome. I'm Pratik Wahi, and in my graduation thesis, I investigated robust design solutions for energy efficient educational buildings in future climate. The Netherlands aims at decarbonizing the built environment by reducing the heat consumption. To achieve that, the primary design strategy is to increase insulation, airtightness, and maximize solar gain. However, these strategies in summer traps the heat like a greenhouse and causes overheating. Now, the overheating is a primary cause of thermal discomfort, and it's quite serious because 90% of occupants spend their time indoors. For students, it's even more. There is a high correlation between thermal comfort and productivity of students. With the increasing outdoor temperature due to climate change, the risk of overheating will certainly increase. Therefore, the research looked into passive design strategies which are climate adaptive in nature, applied at various levels and scales of design. But the main research question is, are these passive strategies robust enough for future? The research employed design by research methods over two case studies, the Pulse building in TU Delft campus and Melanchthon School in Rotterdam. From the research, I found that combination of these passive design strategies can really reduce percentage of discomfort hours in 2050 and 2085 in the two case studies which I mentioned before. Furthermore, concept of robustness is important for designers at early design stage. Therefore, an early design tool called BouT was developed. To see the tool in action, you can scan the QR code at the bottom of the slide. Concluding, I would like to say that climate change is real. As designers, we must look into the future as well, providing comfortable built environment through some out-of-the-box and robust solutions. Thank you.
So while Pratik was already talking about 2085 and looking into the future and how to make our buildings survive these climate changes, we would like to go into the next phase of our presentation by talking about what happens after you graduated from building technology. And in order to do so, we have talked to our alumni, but we'll also have a look on the company side. But first, have a look where our students will end up. According to our recent research, about 35% end up in offices within the consulting topic. 30% in the industry. That's other companies who build our buildings, like products from the sun shading industry, facade industry, but also huge contractors. 20% join architecture offices and become the experts within the office. And about 5% do continue in research in other universities all over the world. And I'm quite happy, and we are very proud to be announced that we seem to be the highest number of 96% of our B2 students who will be hired within 6 months. And that is one of the highest within our overall university. So therefore, we really think that the skill set we are able to teach you are valuable and therefore also needed within the industries. But I think the best is to ask a couple of students how they have been doing and what they're doing right now by looking at their career paths. So therefore, we have asked a few students in order to share their careers and what they have actually taken from the education. Let's start with Aditya. We already met him during the presentation of his graduation, but now he has a different role.
Hi, my name is Aditya and I graduated in building technology in the summer of 2020. After obtaining my master's degree, I was keen to contribute to the sustainable development of the built environment. That is why I joined the Energy Transition Competence Center of Royal Haskoning D.B.S.G. Due to Corona, instead of me going to the office, as you can see, Royal Haskoning has sent the office to me in my home. In the energy transition team, I work with my fellow consultants and engineers to advise companies and municipalities on how they could transform their buildings to make them more energy efficient and future proof. A solid background in building physics, facade design, and sustainable design from the building technology master track helps me to analyze the various technical challenges that revolve around the transformation of buildings and to come up with innovative solutions using various digital and computational tools.
So let's have a look what Anita did.
Hi, my name is Anita van der Brugge and I've graduated from TU Delft in 2010. After graduation, I started working for De Groot & Visser, a facade construction company. I worked there as a commercial manager, doing sales and marketing as well as sustainability. After 6.5 years, I started working for ASSA ABLOY Entrance Systems. Here I worked on specifications, but also on the topic circular economy. Together with a co-worker, I developed a method to become a circular company. I truly believed in this method, and therefore I recently started my own company, helping ASSA ABLOY and other companies to become circular.
Tanya Cortis shared her experience, and let's see where she ended up.
Hi, my name is Tanya. I graduated from Building Technology in the summer of 2019. During my time in Delft, I completed the honors program with the Facade Research Group. I also worked as a teaching student assistant for the Chair of Building Product Innovation, and I helped develop a course about circularity in the built environment. I did my graduation internship with Kinnear, and I did a thesis about circularity in facade systems, which was the perfect hands-on experience for my research. After I graduated in 2019, I moved to California to start working at Callahan in the Los Angeles office, which is where we are now. So let's have a look around. We usually gather here to discuss the different facade systems and our details. For example, this is the very first project that I worked on when I started working at Callahan. It is a timber hybrid building that will become the tallest one in Australia in the next years. It has a serrated facade that spans vertically 4 floors. Another thing that I'm very passionate about and that I learned in Delft from the very first day is about sustainability and circularity. We have been doing a lot of research about how to lower embodied emissions in facade systems and how to make our designs more circular.
And you may also end up doing your PhD based on the stuff you have learned at our faculty.
Hey, I'm Chris Bush-Costanzi. I'm from Malta and I graduated from BouT in 2016. I'm a PhD researcher here in TU Darmstadt, where with my buddy Mario, I'm looking at wire arc additive manufacturing and construction. Yeah, the BouT course, it really surpassed my initial expectations. I mean, on the one hand, we had the Bucky Lab courses, which was this super hands-on approach to architecture, which then was really well complemented by other theoretical courses like structural mechanics or environmental design and so on. In the end, I mean, everybody says it, but it's true. You end up graduating with this diverse set of tools, which, yeah, even I'm using practically every day in my own research now. As an international student, what was also really cool is that you're doing all your research and studying in the context of this old historical town of Delft. And while everybody does end up graduating with a degree, what's also really nice is that you end up with a super international group of friends. So yeah, anybody who is interested in the course, what else can I say? Just go ahead and apply.
Yeah, thanks, Chris. Let's see what Joop has to share. He's an older alumni of ours.
Hi, my name is Joop Heuvels and I graduated in 2008 at Building Technology in Delft. After my graduation, I moved to Berlin to work for Arab as a facade engineer. I stayed in Berlin for 4 years and then transferred within Arup to the facade engineering team in Hong Kong. In Hong Kong, I worked on many exciting projects in China and Hong Kong, including 530-meter tower in China. After 4 years Hong Kong, I moved to London, to Arup, the main office, to join the facade engineering team there. In London, I stayed 3 years, so that makes my Arup time 11 years in total. And during that time, I worked throughout all the stages of the design process, visited many construction sites, visited production facilities, and witnessed countless of facade tests. 2 years ago, I moved back to the Netherlands, and together with Dominique Vosmar, we set up Frontwise Facades. That is where I'm working now. At Frontwise, we offer facade engineering to the Dutch market, but focusing more on sustainability and circular economy. It's a whole new chapter in my career, but so far so good. What I love about facade engineering is solving technical problems within very clear constraints, being part of the design team, and seeing your design being realized in the end. In my opinion, the success of a facade is all in the details. And I always look back very well at my time at BT in Delft. Thanks.
Yeah, so the first 5 examples already shared their career path within the academics, doing a PhD, or within the consultancy or the industry sector. But I would like to ask Mike also, who only did the Bucky Lab as an exchange, but today he is joined the office of Bjarke Ingels, working at BIG.
Hi, my name is Mike English, and I did my exchange program at TU Delft in 2016, and I participated in the Bucky Lab while I was there. Back then, I was interested in doing projects at a one-to-one scale, and the Bucky Lab presented the perfect opportunity to do this surrounded by experts that really taught us all the necessary skills at a digital and physical level to be able to produce these. In my edition, we did an acoustical panel that also had additional performances. And we got the opportunity to present it to the school and also in an exposition in Rotterdam. The skill set that we learned there under Marcel Billow was truly amazing, and it's followed me throughout my career. After my exchange program, I went back to school in Spain and finished my master's, and then went on to work for Bjarke Ingels Group in New York. And right now I'm working for BIG in Copenhagen. And the one-to-one workflow that we applied in Bucky Lab also is a big part of what we do at BIG and has really helped me in my professional career at BIG. So I hope you all consider this this course. It's really great experts, really great people. Thank you. Have a great day.
Thanks for the kind words. I think within these 6 stories of our alumni, you can already see the diversity of building technology. And I won't stop here, but I would also like to share what the companies we often work with, and knowing that they're always looking for our talents, maybe sometimes even before they graduate. So therefore, let's have a look. I'm very pleased to have James O'Callaghan, not only as a colleague, but also as the founder of Eckersley O'Callaghan. And he and his office are most likely known for their incredible glass constructions and most likely be the engineers of all the Apple stores worldwide. But let's see how he thinks building technology can be described.
Hello there. My name's James O'Callaghan. I'm the founding director of Eckersley O'Callaghan, structural and facade engineers, as well as being the professor of architectural glass within the TU Delft School of Architecture, BouT. We have a pretty rich culture of serving good architecture. That's what interests us, and we have an ambition to realize the very best buildings in the world. It's a simple and bold ambition, but it's something that we all are driven towards, and a lot of our work has been very exciting to work on. We've been very lucky to have a number of very excellent clients, and a quick review of our website would see the type of work that we've been able to do, but you'll probably see that within it there is clearly a keen desire to make great architecture real. There's a thread of innovation that flows through all of the work we do and informs the solutions that we give. It's very important that we remain creative. It's very important that we think hard about what those solutions are, and that's important in our overall culture and being. But being good at anything requires a strong sense of curiosity and interest. So that's first and foremost, the most important thing to have with respect to anything, but particularly in building an architecture. You've got to have that interest and you've got to have that curiosity about how things work, why they are the way they are. And if you can back that up with rigor and determination, then that's the greatest characteristic set that we could ever hope for. And from my experience, that is what we get from the students at BK, BT students at Delft, and that's typically the characteristic they have, and that's one I would strongly advise you to aim for in whatever you do and however you do it, but particularly as you continue your studies and go through to your first roles in the big wide world. Thanks very much. I hope to see some of you who've watched this sometime soon. It'd be great to meet you. Bye.
That was James as a structural mechanic. And let's see what Joost has to say. He's from CPZ, and the next minute will be in Dutch.
Hey bachelors, mijn naam is Joost. Ik werk bij CPZ en ik ben ongeveer 20 jaar geleden afgestudeerd als bouwtechnoloog aan de TU in Delft. En Marcel heeft mij gevraagd om jullie te vertellen wat er nou zo leuk is aan het beroep bouwtechnoloog. Maar ik zou jullie allereerst willen vertellen wat er nou zo belangrijk aan is. Nou, als bouwtechnoloog ben je eigenlijk de schakel tussen architect en alle andere ingenieurs die nodig zijn in een ontwerptraject. En je begrijpt de architect heel goed, je kan zijn visie overeind houden en tegelijkertijd zorg je ervoor dat een gebouw maakbaar, bouwbaar en efficiënt wordt. En dat maakt het vak ontzettend leuk en heel erg veelzijdig. Daarnaast denk ik dat er voor de bouwtechnoloog de komende jaren ongelooflijk veel werk ligt en een hele grote uitdaging. We gaan de energiecrisis zitten we vol in. En we hebben de materiaalcrisis. Hè. We moeten circulair gaan bouwen en daar ligt echt een hele grote rol voor de bouwtechnoloog. Kortom, genoeg redenen om te kiezen voor de opleiding bouwtechnologie.
So that was Joost. He's actually an alumni of ours 20 years ago, and he now works at an office. But let's see what our colleagues from IBT have to share.
Hi, welcome at our virtual office. My name is Gertjan Peters and I'm an engineering consultant at ABT with a passion for facades.
Hi, and I'm Erwin ten Brinke, engineering consultant with a passion for glass structures. You consider to choose building technology. Good choice. Many students have already found a place at our office.
In this video, we want to tell you what we stand for and indicate what you can offer us. But first, we want to introduce you ABT.
We believe in an integrated design approach, which will lead to safe, comfortable, healthy, and sustainable buildings. Our main drivers are innovation and sustainability. We take responsibility in social themes like data and digitization, as well as circularity.
We encourage initiative and personal development. We work in teams, we do it together, unbiased and equal. Our goal is to fulfill the client needs, dreams, and ambitions, even if they seem impossible at first sight.
We are looking for new talents who share this goal and mindset.
We are looking for dedicated youngsters who want to work on cutting-edge projects. Are you curious to meet us?
You can attend one of the guest lectures that we provide at the university. We are always open for internship and master thesis. In the end, we are looking for talents to join our team at ABT.
So that was a perspective from a structural engineer. And for those who like to get their fingers dirty, we have our very last part of that shows the industry, Robert Capel from Octotube.
Hi, my name is Robert Capel and I'm from Octotube. We're a design and build company based in Delft and we're specialized in glass and steel structures and mainly building envelopes. We do a lot of work and we start the process of building of a design assistant quite often. So we start with designing, making concepts, checking structures, making technical proposals for a certain design intent, together with architects, structural engineers, and other consultants, among building physics. And then we make engineerings and do actual productions. I'm taking this video here in our workshop, which is in Delft, also right next to the campus. And that's a place that's very attractive for the young engineers who graduated at BT. The link between Octotube and BT is quite strong. A lot of our engineers and project managers have graduated at BT, and there's the link between us is strong because we do a lot of 3D engineering and make parametric modeling for our designs, which is up the alley of the BT students. And what is nice about our company is that not only you make the 3D model, you can also tinker a little bit, work around here in the workshop. Here in the back, you see a sliding roof with an engine-driven rail system for like a telescopic roof that we're building for the city, for a club in the city center of London. And those are all studies, and quite a lot of our jobs are either very iconic or very challenging in their technique, and that's always a quest how to build it. And the quest how to build it is what combines us with BT, and we are a company and we love to hire people from BT. Okay, hope to see you soon, and always feel free to drop by at Rotterdamse Weg 200, right next to the Porcelain Fles, and have a small look around. Okay, bye-bye. Enjoy your days. Bye.
So I think within the last couple of different perspectives, I hope we have been able to share what building technology is about. So in principle, you have to make your choice. You can either choose for the building scale, maybe joining one of our next experimental projects in the fight for circularity in order to make pre-manufactured digitally constructed buildings. Maybe you join one of our experts and leaders in glass research by melting glass and creating the new Chanel shop in Amsterdam. You may end up getting your hands dirty, work with digital and analog tools in one of the Bucky Lab workshops, for instance, and end up as a product designer, designing wonderful sunshades, for instance. You might also choose to tame our robots within the chair of design informatics. Think about how digital production techniques will help us to increase the speed of our building progress. And you may also find yourself to become an expert in acoustics, and in this case, also in a 3D printed prototyping stage that allows techniques and forms that are not possible with the standard techniques. You might also be the next one who tackles the opportunities of load-bearing structures in glass, as he is seen on a building fair with the glass swing. You may also end up with an interest in glass constructions and figure out how a structural bridge out of glass could be made. As already shared with the more team of the Solar Decathlon competition, you can also share on a building scale and actually build this building, which will undergo 10 different categories of this Decathlon project in order to find your place within the realm of building technology. You might already fall in love for the bigger structures, like this glass roof, for instance, or you may actually be able to join our teams in order to improve our own campus, as seen here as a setup experiment for a lease facade, and try to solve all of the problems we already have on the campus within these research and educational projects. Last but not least, you may become the next expert helping the new Apple stores to become reality. And if you're still unsure if building technology has the right tasks for you, the right competition challenges for you, feel free to look at our repository and have a look what our recent students have done within this broad field from high rises, bridge construction, material development, digital developments, 3D printing. I can't name them all. And I hope I'm able to visit you at one day on a big building site like I did with Paul, overseeing the harbor of Rotterdam, building new infrastructures for our built environment. So, building technology. I hope we have been able to share what building technology is and why we do this. And I would like to end with a round for Q&A. Thanks. I can't hear you.
Sorry, I was on mute. So we already have our first question, which is how does building technology contribute to a design team? In what amount are you part of the designing itself?
So in principle, it's if you look at an architecture project, you will have one architect and about 10 to 15 experts from within the disciplines of building technology. So therefore, it's a huge team. There are more experts than architects involved. And as I've mentioned earlier, while the building technology expert becomes the friend of the architect, it should always go hand in hand. And from my own experience within an office for facade consultancy, we have set next to the architect already within the competition and first design steps in order to have an equal discussion about the architect's dreams and the possibilities to make that reality. Therefore, I can say I was involved in many, many of the great projects we have done at a very early stage. And therefore, I'm also proud that these ideas from my side became reality. I hope that answered that question a little bit. I think there's a very big involvement of these parties.
Thank you, Marcel. So no more questions then?
It's kind of like last time I was also asked from a student, why should I pick BT? I love architecture so much. And I can only respond that I did the same. I really love architecture, but being an expert within that field, being on the consultancy side, you are able to work with Sahadid on a Monday, with Norman Foster on a Tuesday, and with Snohetta on a Wednesday. So therefore, you will be able to do multiple architects within your time. While being at the architect's office, you have to choose, and then you have to at least stay for a couple of years to get to know what they're about to do. So therefore, from the other side, it's quite interesting because you will visit these offices and are able to work with them all at the same time.
Thank you all for. Sorry, Marcel, you were saying something.
No, I was just asking if there's more questions.
No, we don't have any more questions. So I'd like to thank you, Marcel, for your presentation and giving such a nice overview to our students. And I'd like to thank all the students for joining the second day of BOUWHOUSE Symposium. We hope to see some of you in the workshop this afternoon. If you haven't signed up for the workshops, you can send an email to masters@stylos.nl so that we can send you the Zoom links. Thank you all.
Thanks for having me. It was a pleasure, and hope to see a few of you in the workshop that we will start afterwards. Thanks. Bye.